Hi, Coach Travis here, and there's a question here about Rolle's theorem and the mean value theorem. So I can definitely understand this question and why this question would come up, because Rolle's theorem and the mean value theorem are very closely related. That's what you should understand, is that they're very closely related, and so it can be kind of confusing sometimes. Well, which one's which? And so the question is, can both of the Rolle's theorem and the mean value theorem be applied? And how do we know which one to use? And so the simplest way to think about it is you actually never need Rolle's theorem. The mean value theorem is like an improved version of Rolle's theorem. That's really the honest way to think about it. The mean value theorem is the same thing as Rolle's theorem, but even better. So, so in that sense, any problem that you can use Rolle's theorem on, you can also use the mean value theorem on, because the mean value theorem is like Rolle's theorem, but better. And let's kind of just look at some pictures to see what that's about. So what I'm demonstrating here is a picture about the mean value theorem. So the idea is, suppose I have some weird function here. So this black curve is some weird function, and then here's a tangent line. This red line is a tangent line. And what the mean value theorem says is, it says that, okay, well, notice there's this dotted line that connects the endpoints. So what the mean value theorem says is, it says it's always possible to move this tangent line so that it's parallel to the blue dotted line. So you can see that, oh yeah, if I was allowed to move this red tangent line, I could make it parallel. And if I change this function, okay, if I change this function, well, what if it, yeah, Travis, what if it's a different function? Well, can I move this red line? So can I move this tangent point so that the red line is parallel to the blue line? And the answer is yes, I can. And again, we can keep playing, we can keep messing around. You can make this function as crazy as you want, but it's all, the mean value theorem is always going to say that you can make the red tangent line parallel to the blue dotted line. And now let me be a little bit more careful there. I said no matter how crazy this function gets, that's a little bit of a lie, because the function has to be continuous and smooth. So as long as it's a continuous and smooth function, then you can win this game. But if you make your function really crazy, like if it has asymptotes and discontinuities and stuff, yeah, then all bets are off. Okay, so that's what the mean value theorem says. And now what Rolle's theorem says is, Rolle's theorem says it puts a more of a restriction on your function. Rolle's theorem says that the endpoints have to be at the same height. So Rolle's theorem says I can make these middle points wherever I want, but I have to make the endpoints the same height. But now let's think about what the mean value theorem would say. The mean value theorem would say that I can drag this red point so that the tangent line is parallel to the line connecting the endpoints. And sure enough, that's right. We could do, you can see that we can definitely do that. But the issue here is that, well, these lines are special. Like this line, this blue dotted line is a horizontal line. So it has slope 0. And so if this red line is parallel to the blue line, then this red line also has to have slope 0. And so that's what Rolle's theorem says. Rolle's theorem says that if your starting point and your ending point are at the same height, then there has to be a place where the tangent line has slope 0. And we can see that if we move these points around, we can still see that, yeah, there's going to be a place, as long as I keep the endpoints at the same height, as long as I keep the endpoints at the same height, there is going to be a place where the tangent line is horizontal. So that's what Rolle's theorem says. Rolle's theorem says if the start point and the end point are at the same height, then there's always going to be a tangent line with slope 0. But again, notice the mean value theorem says the same thing. The mean value theorem says that no matter where these blue points are, if it happens that these 2 points are at the same height, then the line connecting the 2 points will have slope 0, and therefore I can drag the red dot so that the tangent line also has slope 0. So I hope that made sense. So the moral of the story is Rolle's theorem doesn't add anything to the mean value theorem. Rolle's theorem is just a special case of the mean value theorem. So the mean value theorem is like I said, the mean value theorem is the same thing as Rolle's theorem, only it's better because the mean value theorem says you could move these points. It says the beginning point and the end point don't have to be at the same height. But of course, the mean value theorem says, well, they could be at the same height if you wanted them to be. The mean value theorem doesn't care. They could be at the same height or they could be at different heights. And if they're at the same height, that's just Rolle's theorem. And the mean value theorem already covers that case. So you might wonder, well, why do we even bother with Rolle's theorem? I mean, if the mean value theorem is the same as Rolle's theorem, but even better, why do we even talk about Rolle's theorem? And it's mainly for historical reasons and for proof reasons. That if you want to prove the mean value theorem, it's easy if you use Rolle's theorem. So it's easy to prove Rolle's theorem first, and then use that to prove the mean value theorem. And that's kind of why we do Rolle's theorem. But in terms of what you walk out of this class knowing, if you know, I want you to know the mean value theorem. If you forget Rolle's theorem, that's not really a big deal as long as you know the mean value theorem, because the mean value theorem, like I said, is the same as Rolle's theorem, only better.